Hey everybody, welcome back to the HUGS. I am, as usual, your host Chili, and today we're going to ask ourselves an important question. See, the name of this engine, if I am not mistaken, is the thrust engine, right? And if we start this bad boy up, what are we missing? We got the ship. It's moving through space, but there's no thruster. There's no indication of the method of propulsion. Was it giant magnets? What is it? I don't know. Could be anything. Where's the thruster? Lebowski. Where is it? So I went and I made a thruster for this, as you could expect. It's kind of my job. I mean, it's not my job. My job is translating Japanese into English, but I can do this stuff too. So let's take a look at what Chili has wrought. We're going to build this bullshit. And we're going to see what kind of thruster I made. Again, we're going to skip this. I freaking hate this window. It always moves into the wrong spot. I got to change that. But I won't. Alright, get that thing out of the window. Now check this shit out. Look at this fucking sweet ass thruster here. Is this not the fucking sickest exhaust plume that you ever saw? Fucking sweet. And you got the sound effects too. Jesus Christ. I am firing on all cylinders here. So that's the thruster. Now, the question is, how did I make the thruster? Well, that's the topic of today's little foray into programming. We're going to talk about the thruster graphics and the sound effects for that. I'm going to be able to loop some sound effects. So, question: how is the thruster made? What is it composed of? It is not an animation of sprites, I'll tell you that. It's actually just a whatchamacallit. Yeah, one of those. It's like a vector graphic, much like the walls are, and much like the old ship was before we implemented the old textured quad. Oh, by the way, you might have noticed I changed the graphic of the ship just basically for shits and giggles, but that's not a big deal. I'll talk about that when I get into the code. The important thing is this thing. How do we do? How does it go? Now, you might remember back in the old advanced series, we had the ship, and it was loaded from a DXF file. And that DXF file gave us a polyclosed, which we then triangulated, something like this, generating, a plurality of triangle strips, which we then rendered to the screen. And that's what we want to do with this thrust. We got a .dxf file. We're going to load that into a polyclosed. We're going to go, poly closed blah something x.dxf. And after that, we want to extract the strips from that. And we'll load that into some member of the ship and then draw it when we want to. It's all good except for a couple problems. First of all, the way the engine is right now, we can't load a polyclosed. We can't create a polyclosed by itself. It won't work. That's problem number one. I'll get to that in a second. Problem number two is the extract strips function does not exist in the current engine. It was in the advanced engine here, but I didn't port it over to this engine because we're using the textured quads now. So we never had a need for it. The walls were done with a different algorithm. They aren't done by the triangulation. So what we want to do, first of all, is we want to fix polyclosed. Now, what do I mean by that? Well, let me go back to the star alax branch, and let's look at the class view. So here we've got polyclosed, and derived from polyclosed is polyclosed rebounding and track region. Now, the way this works is polyclosed contains a few, well, it contains one thing in particular. It contains the, where is it? Handle collision pure virtual function. And because it contains a pure virtual function, it can't be instantiated. We can't make a polyclosed. We can only make its child classes, which are concrete classes, and they provide the implementation for handle collision here. So, polyclosed has a pure virtual function, and it is not allowed to have one of those. So we need to fix this. Now, the thing is, polyclosed shouldn't have any of this bullshit handle collision. Shouldn't have test collision, because that is a physics. These are physics concepts. They have to do with physical objects, and polyclosed is, at its heart, only a geometrical construct. So, what we're gonna do, what I have done, is let's go change our branch again. Let's go back to the thruster branch, and let's look at the history. All right, here we go. So here's all the changes I've made. So first change ship graphic. It's not a big deal, obviously. Add the new ship graphic and change some parameters, the center point, the scaling, and so forth. Here, change the name of the graphic to be loaded, obviously. This is not nothing to be surprised about. Next thing, oh, here's one thing I did before I actually separated physical and geometric things from polyclosed. And that is, I finally got rid of all the dumb const bullshit inside of templates. So whenever you see this thing here, like standard vector const vec2, that's now just vec2. And that is good because this is actually not standards compliant. It compiles in Visual Studio 2013 and before, so I figured it was okay. But it's not okay. And that's fine. I mean, ideally, when you think about it, having const template types for a container doesn't make any sense, because containers are inherently, the contents are inherently meant for value semantics, which means you should be able to move them around inside of each other, just like ints, copy them and shuffle them around and so forth. And making them constant is kind of like going against that grain. So it was a dumb idea to make these constant, and I have rectified it, at least as much as I could find. Probably all of them. Maybe I missed some. You can let me know if I have, but people were having trouble building this in 2015 because of this, so I apologize for that. No harm, no foul. So I got rid of that dumb bullshit, and next thing is the important thing, the thing I was talking about. Pulling out all of the what's? Pulling out all of the physical stuff, all the physics code from polyclosed. Let's get rid of this bullshit. It's clogging up my screen. So I pulled out the test collision function, and I pulled out the handle collision pure virtual function there. And what is all this bullshit about? Oh, I think this is just, I just reformatted, add some spaces in there. I don't know. Who cares? That's dumb bullshit. Doesn't matter. Yeah, I got rid of some spaces here. Whatever, that doesn't matter. The important thing is that I pulled out the physical circle from here. I pulled out a lot of stuff. I'm basically the pullout king. If you didn't know, I'm really good at pulling out. So I pulled it all out and I put it in a file that you can't see here because of fucking Visual Studio fucked me over, but let me show you the file. And it's in physics and polyclosed physics. Wait, did I call it polyclosed physical, I think. Let's get physical. I want to get physical. Let's get indivisible. So I make this polyclosed physical inherit from polyclosed, and all is good. And now you have the test collision code here, and you have the handle collision pure virtual function here, and then our good old friends polyclosed rebounding now inherit from polyclosed physical. So now polyclosed is free to be instantiated as a concrete class. Good stuff. Now the reason why you don't see polyclosed physical in here was because somehow it got ignored in the Git tracking. So it got put in the do not track list. So it never got added to this commit. And I only found that out when the first time I tried to record this video, and I looked at it and I was like, it's not fucking there. So that was good times. Fuck you, Visual Studio, for randomly putting files into the do not track list, you fucker. Anyways, doesn't matter. So, separation of church and state, and we are all good with the polyclosed. So now I can add the polygon triangulation routine back into the code. And that is added into polyclosed, I suppose. Yeah, it's right here. The function is extract solid strips, and I renamed the function that generates the wall strips. Where is that function? Yeah. I originally it was being called extract strip vertices, which isn't very descriptive. I changed that to generate wall strip. So that just makes things a little bit more obvious as to the difference between these two functions. I'm not going to go over the details of this algorithm. It's pretty involved, and I think I covered it sort of in the advanced series, although I might have skimmed over it. It's all commented though. You can try to follow it. If you really want to know, you can ask questions about it. I'll be happy to answer them. But in general, all you need to know is that it works, or sort of works. We'll get to that later. And it will do this. It'll generate a vector of triangle strips that basically cover the entire image here that you generate it from. The contour. It will generate a solid from a contour, is what I'm trying to say. And that's good. That's good times. Just maybe some renaming here. I don't know. I should probably just pull this open. I could tell what it is. Yeah, I just kind of renamed some bullshit here. Renaming bullshit, and add triangle strip into here because it's needed now. And that's about it. That's all you need there. In map, obviously you got to rename extract strip vertices to extract wall strip. In ship, this doesn't matter. Don't worry about that. It's not important. In oh yeah, so we got to add the list here because it's needed apparently somewhere. I don't know. Doesn't matter. And here I added, what did I add here? I added a move constructor, I guess, because it's always good to have a move constructor, right? It leads to more efficient transfer of data. And here I added a couple of just utility functions for triangles. These are used inside of the extract strips routine. This one just tells us if a corner, basically you give it 3 vector points, and it'll tell you if those 3 points represent a convex relationship or a concave. That's just, let's say you got 3 points like this, 1, 2, 3. It'll tell you whether it's convex or concave, and that all depends on the ordering of the vertices, whether you're reading your vertices clockwise or counterclockwise. And this one just tells you if a triangle contains a point, which is very useful in a lot of different situations, but certainly useful in the situation of triangulation. So there you go. You got your triangulation routine all up in there. We in there. Now, implement simple thrust effect. This is where I actually give my first try out on the thrust effect. And what I'm doing here is let's see what we're doing here. Ship, and so I add thrust.dxf. See if I can open that. I can. This is what it looks like. This is the first draft of my thrust outline, the contour of the thrust. And the way it's implemented in code is, first off, we got some data we put in here. We got the vector of triangle strips. We have the offset of the thrust triangle strip, the thrust model from the center of the ship. Because obviously you don't want to draw it at the center of the ship. We want to draw it coming out of the back of the ship. Want it to come out of the butt. And so we put an offset on there. We scale it to make it, a good size. And it's got a color that it's going to be drawn at with bloom. Obviously, we're going to have a big, nice bloom number in there. Get some bloom going up on there. And here we load the thrust strips. Just like I said, you load a polyclosed and then you call extract strips on that. And then that gets moved into this constructor here. And up here is where we draw the motherfucker. So we are only going to draw a thruster, obviously, if we are thrusting, and then we build a transformation, which is the transformation from the camera, a viewport chain, concatenated with the translation from the center and the scaling. So we scale it, we translate it, and then finally we perform the chain transformation. And then we just iterate through all of the strips, transform, clip, and rasterize. And that is how that goes. Not too complicated. I want to show you it, but the problem is I don't think I can show you it. Well, first things first, in order to show it to you, what I've got to do is I have to go to the folder here. I've got to zoom out a bit. And then I can go Git GUI here. And first off, before I do that, let me go back into the folder. I'm going to save a file. No, let's go to release. No, fuck you. Go to engine. That's the one. That's the ticket. We want the thing that did not get saved to the commit, which was polyclosed physical. That starts with a P. So we're going to copy this to my desktop. Then we're going to go back to the Git GUI. We're going to visualize all branch history. We're going to create a branching point on the first simple thrust effect. Create new branch. I'm going to call this HUGS 16A. Create that. Then we're going to check out this branch. All right. Now that we've got the branch checked out, reload. Now we're going to try to build it. And it's going to say error, cannot open file polyclosed physical because it's not fucking in there. Because fucking Visual Studio. Oh, I hate you so much. Anyways, what we're going to do is we're going to now open that folder. We're going to drag polyclosed back into here. Now we're going to build it, and it's going to work. And then I can show you what for. So this is how my first kind of little test for that's a nice effect. That's how my first test came. Looks like this. It's kind of, I don't know. I mean, it's okay, I guess, but it's kind of underwhelming. It's not animated in any fashion. It's kind of small. It's not very big. That's what she said. But it's, it's a thruster. It's coming out of the butt, which is an important part of thrusting. So that is that. Let's see how we can make it better. In order to do so, we're going to go... Where are we going to go? I'm going to go here. Git GUI. No. Go to this one. Yes, we'll switch back to this branch. Why did that happen? That was weird. All right, so maybe we're not going to... Maybe we're not going to switch out of this branch, because I don't know. Some shit just went down. Changes. Okay, there's no changes here, so we should be able to switch the branches. Right now, we are in untracked branch 816A, unpublished, I should say. Go back into thruster. Cannot switch because they're uncommitted changes. The fuck you say? I didn't make any goddamn changes. You're a fucking liar. Shut your lying mouth. Changes. Untracked files, excluded, included. Okay, so there's no changes, and yet there are changes. This is a fucking shit show. I should have never come on to this. Yeah. Okay, what I'm going to do is I'm going to delete this. No, scratch that. I'm going to delete this. Because that doesn't belong here. It's not in continuity with this timeline. And then what I'm going to do is I'm going to go branches, and I'm going to try to change my branch now. I'm going to go to thruster. It worked. Good. Okay, so I don't know what the fuck the problem was there, because that file wasn't supposed to be tracked in the first place. But anyways, we're back in our thruster branch. Now we can go and once again view the history. So here's where I was at for so rudely interrupted. Implement simple thruster effect. Done. Next thing we want to do, two-part thrust with random stretch modifier. So what I've done here is, I mean, I modified, I don't know why it doesn't open this thrust in the fucking, yeah, there we go. So I've modified the thrust a little bit. I've made this part rounder, and I've made the center spike stick out more. So I feel that is a more aesthetically pleasing arrangement. And the second thing is I've added a second highlight to the thrust. And this one is going to be drawn on top of the previous one. And it's going to be drawn with a brighter color. The color will be closer to white, and it will have a higher bloom number. And that is going to make it sexier. So the way this works is, obviously, we now have two triangle strips for the thrust. And we have this number here called the intensity modifier. It's just a random number, and it's basically a percentage. It's going to run from, on average, in general, it's going to run from about negative 20% to positive 20%. And that is going to modify the intensity of the thruster. It's going to modify the length, and it's going to modify the girth, and it's going to modify the bloom of the thruster. So we've got two colors here, one for the thrust proper and one for the highlight. We've got a random number generator that generates the intensity, and a normal distribution, which distributes that, normally. Gaussian distribution with standard deviation and a mean. So what we got here in the constructor is we load the two strips, we initialize the random number generator, and we initialize the intensity distribution so that the mean intensity modifier is 0. So on average, the intensity will be just the value that I've set it at. And the standard deviation is about 20%. So it's going to vary in general from around between minus 20 to positive 20%. But of course, it can be more or less than that. It's a distribution. Just in general, that's the standard deviation. I guess that's what it means. I don't know. I'm not a fucking statistician. I just plug numbers into these things, and when it looks sweet, I'm like, fuck yes, I'm done. Anyways, so what we do is in the update, we update the intensity modifier. That's the only thing we change in the update with relation to the thruster. And in the drawing section, here, what we're doing is we're stretching the thruster model by, time multiplied by 1, scaling by 1, is the same as, just leaving it the same, right? But then we add to that the intensity modifier. and we scale the intensity modifier down by 1/3. So this is a stretching operation. It's different than scaling. Let's take a look at that. We'll go into matrix 3. So scaling will scale the x and the y by the same factor, but stretching allows you to scale the x and the y by different factors. So you won't maintain the same aspect ratio. You're going to have some kind of squishing or elongation effect happening. And that's what we want. We want the thruster to be elongated in the longitudinal axis. So what I'm doing here is I'm scaling the y by basically by thrust intensity percent, minus 20% to plus 20%. But the x, I don't want to scale it as much as I scale the y, because I want the varying to be mostly in, in this direction here. I want the thruster to be moving in and out like this. Your standard, piston motion. What I'm trying to say. It's not going to vary so much in the girth. It's mostly just it's all about the length is what I'm trying to say. The girth is not so important. So, so we scale the girth by 1/3 of what we're scaling the length by. And that is how we generate the transformation matrix for the thruster. Then we're also scaling the bloom factor by a little bit. This is for the proper thrust, and this is for the highlighted thrust. So here we're scaling the bloom by just a little bit, just a wee bit. See, we're scaling it down quite a bit, the intensity modifier. But we are scaling it. We're varying it a little bit. We're throwing it up. I forget the words now. Can't talk anymore. Brain broken. Let's continue. We're mixing it up. That's what I wanted to say. I don't know if that's any better, actually. Whatever. Here we're doing the same thing. We're drawing all of the strips for the original model, and here we're drawing the strips for the highlight model. And that, my friends, is it. That's all she wrote. That's all you need to make a fucking sexy thruster. That's it. Now, the next stuff here is what happened when I tried to add looping into the sound code. And let me just say, it was a major clusterfuck, but it came out quite well. I'm impressed. Pat me on the back. Way to go, Chili. So the first thing that happened when I tried to add looping into the motherfucking audio code is it didn't work. So then I put the fucking program in debug mode, and I found out that there's a bug here in the polyclosed triangulation. The bug, what did I change here? Oh, ignore this. I added this for debugging purposes and I forgot to remove it. Oopsie daisies. Doesn't matter. The problem here is this code that is supposed to rotate the list so that the item that is at the end ends up in the middle. It didn't work that way. It just fucked things up. And that was bad. It randomly created a frickin' psychedelic effect on the thruster, but it's not important because I fixed it. So I fixed that, which was in there for like years already, and I never found it before, which is kind of weird. But anyways, I fixed it. Next thing I fixed was, what do we got here? I got my friend constant. So I've got some constant member variables here. And that's not a good scene. I've talked about this before, but you don't want your memory variables to be constants. You can have pointers to constant and you can have references to constant, but you don't want a constant pointer or a constant int, because first of all, if you try to put this thing into a container, it's not going to work good, because containers want you to be able to move things and copy things, and constant members are they're cancer for copying, right? It doesn't work good. And in order to fix that, previously what I had to do is I had to use the old, where is it? The old the old const cast, which is, you should probably never use that. But I was using it, and I repent. And I wish for the gods of C++ to grant me their, whatever you call it. Grant me 72 virgins, I think that's what you get. I don't know. Doesn't matter. What we're doing here is we got rid of that shit. And it feels good. The other thing that I got rid of, and that the reason why I started this whole bullshit tour, is because I found another error wherein I was allocating this buffer without using the proper aligned malloc routines. And that's a problem because when I free it, I'm freeing it with aligned free. So if you free with aligned free, you gotta allocate with aligned malloc. And I wasn't doing that, and the compiler, not the compiler, the debug runtime said, "What the fuck, Chili? What the fuck?" So I fixed that, and it was good times. Next thing that happens is when I was trying to debug the sound, I found out that the sound objects weren't being destructed when the screen was being destroyed. When the game screen was being destroyed, the sound objects were not being destroyed. And I was like, that's fucking weird. And the reason it was not being destroyed is because I forgot to put the virtual destructor in screen. So as you know, game screen and all the other screens, they inherit from this. But the actual pointer, the screen container pointer that holds the game screen or the title screen or whatever, is just a standard screen. So if you don't make the destructor virtual, then it's only going to destroy the stuff that's in screen, which is the nothing really, just a pointer to the parent. It's not, and it's not going to destroy that because that's just a pointer, right? It's going to destroy the pointer. It's not going to destroy the parent, right? What I'm trying to get at is all the stuff in game screen. Let's just take a look at that. All this stuff not getting destroyed. Just chilling out, just hanging out in memory, just chilling out there like a big old turd and ruining my day. So, moral of the story is you got to make your destructors virtual if you're going to be, using polymorphism. If you're using polymorphism like we are here, you got to make those destructors virtual. You got to get on that shit. And I did. And it's all good now. Chili has saved the day. All right, another problem that I found a lot of problems, by the way, trying to fix trying to make the sound work. Found out a whole bunch of problems. So GDI plus, the solution that we had for initializing the GDI plus subsystem and destroying it in the proper order was, where is that shit? Where's the fucking framework? Here it is. So the GDI plus manager. And I was pretty proud of myself for this one because what this does is just with some simple constructor and destructor, this allows us to initialize and uninitialize the GDI plus manager without having to write lines of code in the constructor and destructor, simply by including this object, embedding it in another object, like for example, embedding it in D3D graphics. Down here means when D3D graphics is initialized, GDI plus is the first thing that is initialized, and when graphics is destroyed, GDI plus is the last thing that is uninitialized. And that's good, because you want GDI plus to stick around as long as you're calling GDI plus functions. And that's great. That worked pretty good until I fucked it up. And how did I fuck it up? Well, what I did is I made game inherit from screen container. And what that means is that when you create game, first the parent class stuff is created. So first the screen container part is created. Then the game stuff is created. So then graphics is created, input, timer. And when you destroy game, this is destroyed. Wait, no. This is destroyed. This is destroyed. This is destroyed. then the parent stuff is destroyed. And what that means is that the GDI plus gets destroyed before the screen container. And the screen container points to the screen, and the screen, let me just go to it here. The game screen contains, among other things, fonts, which contain GDI plus objects inside of them. So you destroy GDI plus before you destroy the font, and then when you try to destroy the font, the debug runtime says, what the fuck are you doing? You're calling GDI plus destructor functions. I already uninitialized that shit. What are you trying to pull, Chili? So I said, okay, you got me. And my solution to that was to make game not inherit from screen container and just add screen container as a member of game. So instead of screen container or game being a screen container, it now has a screen container. And that means that GDI plus is initialized before screen container. Not a big deal. But what's more important is the screen currently being held is destroyed before GDI plus is destroyed. Very important. So that's that. There's a little bit of long-winded explanation there, but it had to be done. That's the kind of little bug that can slip by. Now, here is where I actually finally fixed my problem and got the looping to work with X audio. Burp time. Excuse me. All right, so here it is. It's not that complicated. What it is, okay, first off, I add two variables to the sound class. And those variables are the loop, the start point of the loop and the end point of the loop in samples. So the start sample index and the end sample index. And the way it works, the way you play a looping sound is, it's not in here, it's in sound.cpp. So basically when you're playing a sound, you set in the X audio buffer, you set the beginning point of the loop, you set the length of the loop, which is this difference between the start and the end. And most importantly, you set the loop count equal to some number of loops that you want it to loop for, or you can set it to the special value X audio 2 loop infinite, meaning just, loop forever. So we check to see if the loop start is not equal to FFF. I set FFFFFF to mean that we are not looping. It's just a one-off sound. And if it's not a one-off sound, then we set up the loop values. Otherwise, we set the loop count equal to 0, meaning that we don't want to loop. And that's all we had to change here to enable looping to happen. But the more difficult problem, well, there's two problems. One problem is how do we actually determine where to loop from? I mean, we could basically just we could pass in the loop points into the constructor, and then we have to hand code them into the code, and we have to determine them, by trial and error or whatever. It seems like a pain in the ass. It's not a very good solution. A better solution would be to embed the loop points in the actual wave file. And there is actually, in the wave file format, there is... oh, shut up. That's not what I wanted. There is a provision that allows you to embed cue points into the wave. Oh, shit. Well, I wanted to show you the cue points, but I can't because I'm using SoundForge right now to actually record the audio of the frickin' shit. I'm using SoundForge to record the system audio while I record my microphone audio with Camtasia, because Camtasia is a little bitch and it won't allow me to record them both at the same time. And now I can't open up this file in SoundForge because I'm recording in SoundForge. Fuck you, SoundForge. Fuck you, Camtasia. So, what I'm going to do is, first of all, I'm going to show you something, and then I'm going to close SoundForge because I won't need it anymore. And then I'm going to show you some other stuff in SoundForge. Good. So, the way I made the sound, this is the sound effect, by the way. I think it's pretty fucking sweet. It's a good thruster sound, and the way I made it was I basically just layered together 3 sounds together. Together. The first one is the rocket one. It's kind of a boomy rocket sound. Second one is more of a thrusty rocket sound. It's got less, less vibrato, I guess is what you want to call it. And the third one is the sound from basically from a medium-sized yacht engine. And I layered these 3 together, and I ramped up starting from the beginning of the sound, I ramped up the volume, and also ramped up the frequency, the pitch on a couple of the sounds to give you a nice little ramping up sound there in the beginning. And that's all the sounds there. So, now that you've heard the sounds, I can stop recording the system audio. Let's stop that. And then I can try to open this up. I'll close that. Alright, so here's the sound, the system sound from this video. Now if I try to open the thrust loop, open with SoundForge, it'll work. And it does not have my loop points in here, because I guess, fuck me. But anyways, doesn't matter. So what you do is you select a point in here, and you go Special, Regions List, Insert, and you insert a region here. There's your region 1, and you go here, Special, Region List, Insert region 2 in here. And then you can save that dumb bullshit. Save it. And there you've got your loop points. In actuality, you're going to have to look, and you're probably going to want to stop them at a 0 crossing point, moving in the same direction. So if your wave file, like let's say you put your loop point here, you're going to want to put your end loop point somewhere similar. This is not good because you see here we're not at a 0 crossing. We'd probably want to put it like here maybe, or maybe even here, somewhere that looks similar to where we start over there. Otherwise you're going to get you're going to get like a popping sound. It's not going to be a good time. You don't want any discontinuities in either the time domain or really the frequency domain. But anyways, so you set up your looping points, and when you do that, let's take a look at this file in a hex editor. When you do that, you're going to get something like this, and at the end you're going to see this. This is the Q part of the wave chunks. Remember when I talked about wave files, you know that the wave file, which is the file format, is actually called RIFF. It has a bunch of different chunks. It's got a chunk for the wave format, the format chunk right here, and it's got the data chunk, and here you got another chunk called the Q chunk, and it contains the Q points. And so what we're going to do is we're going to search for the Q chunk. Oh, I just fucking edited that. I didn't want to. Ooh, I just deleted that. Okay. Well, Control Z doesn't do what I thought it did. I'm going to close this now. Not save. So anyways, like I was saying, Q chunk contains our data. So what we want to do is we want to load that. That's what I do here. First, I change the constructor. I allow you to specify in the constructor whether or not you're looping. And if you are looping, then we search for the Q chunk point. This is the same procedure as searching for the other chunk points. I'm not going to go into it again. If we find the Q chunk point, then we're going to load the individual Q points. And the individual Q points, they have a structure like this. So the first bit of data in the Q chunk is the signature. And the second bit of data is the size of the chunk. We load those two things in. The next thing we check, the next bit of data is the number of Q points. So we want to make sure that the number is exactly 2. Then, if the number is 2, we set a pointer to point to the first Q point, which is the thing after the number of Q points. And then we just use your standard array notation here to load the frame offset from the first point and the frame offset from the second point. That is the actual position of the cue point in the wave file, and then we're done. And we throw an exception if we did not find a suitable cue chunk, and that's it. Bob's your uncle. The other changes I made here are mostly just OCD. I changed this from constant int to constant unsigned int. Not a big deal. So that is the problem of loading the loop points. The other problem that I was talking about is the problem of being able to stop the file, in the middle of playing, because it's looping infinitely. Obviously, we want to be able to stop it at some point. And the way we do that, well, I basically created two functions, stop one and stop all, because a single sound can be played on multiple channels. That's the whole idea of this dumb X-Audio2 system that I created. So stop one stops one of the channels that's playing the audio. Stop all stops all of them. Not a big deal. I just thought I'd add two different options in. Now, in the destructor for sound, the original destructor, the first thing we did was we stop all the channels that are playing, and then we wait for them all to actually die. So instead of having that code duplicated in here, now I just call stop all from the destructor, and then again do the standard wait for everything to die. I did make one modification here, and I call the yield function. And what yield does is it basically it puts the current thread, the thread that's running this code, and it puts it at the back of the execution queue. So it stops it and it puts it at the back. And that allows other threads to work. And the reason for that is that this thread is basically all it's doing is it's locking and checking to see if there are any living threads. And if not, it just tries again, locking again. It's spinning. It's spinning and it's repeatedly polling this variable here, basically the size of the channel pointers. And that's just wasting CPU resources. It's just spinning its tires here. So if we're going to spin, let's spin a little slower and let's yield a little more. Let's let the other threads do a little more work if they have real work to do. And we don't have to spin that hard. We'll eventually reach the state where we can leave this spin lock here. So I just add this yield in here, and in theory it should make this thing a little more efficient. It's not a big deal, but I thought I'd add it in there. And that's it. I added thread in here so that I could use the yield function. And sound.cpp, I've already shown that. And in ship, now what we've got is, so if we are thrusting, if we're not thrusting, so I changed this now so that the thrust function only functions if we are not thrusting. And if we are not thrusting, we set it to true and we play the thruster sound. And for stop thrusting, if we are thrusting, we set it to false and we stop thruster sound. I put it to stop one because really there should only be one playing at any time. And I wanted to make sure that if there was some weird thing that I was not aware of, I would be made aware of it by, the sound not stopping. So if by some freak accident, two thruster sounds ended up playing at the same time, stop one would stop one of them but leave the other one running, so I could tell. But in theory, you'd probably just want to put stop all here to make sure that the thruster stopped when your stop thrusting thing worked, but doesn't matter. Here I just changed the sound volume of the collision a little bit to scale it to match the sound of the thruster. And what else here? Oh yeah, if the ship is destroyed, make sure to stop the thruster. Probably don't want the thruster to continue sounding after the ship is blown up. Probably would not be a good scene. There you go, you add the thruster sound there. And you add the thruster sound constructor there. And Bob is your uncle. And that's it. That's all she wrote about the looping the sound. OCD strikes again is obviously just my OCD. Again, I missed one spot for this constant int to constant unsigned int. So I had to change it. Doesn't matter, they both work the same, but I just wanted to make it an unsigned int. Had to do it. Don't judge me. And last but not least, I added polyclosed physical into the project because the fucking Visual Studio excluded it from the tracked files. Little bitch. I'll get you. I will get you, Visual Studio. I'm gonna upgrade you. You're gone, 2013. I'm switching over to 2015. You're last week's news. You'll never work in this town again. Okay. So that's it. That's all she wrote on the old thruster. And as you could see, well, let's just run her again for old time's sake, shall we? As you can see, she's a big, beautiful girl. Independent woman, doesn't afraid of anything. All that good stuff. Looks sexy. Look at how sexy that is. That's just so good. I'm loving it. All right, so in the next episode, what I want to do is I want to add some music to this motherfucker, but I'm ironing out the little details of that lesson. So it'll happen when it happens. Hopefully sometime next week. And the good thing about the next lesson is, along with teaching you how to play music, I'm also going to teach you about thread synchronization. It's kind of like a little sneaky way to sneak that topic in there. So we're going to learn about all the good thread synchronization bullshit. Mutexes and condition variables. I mean, we talked a little bit about mutexes in the X audio thing, but we're only just a little bit, just a tip. Now we're going to go in there balls deep, son. You're going to love it. But that's this episode. I hope you enjoyed it. And if you did, press the like button because it helps me out a lot. And it just makes you a good person, really. And until next time, I'm Chili. See you later.